Hi everyone. In this video, we will try to see one of the applications of Newton's third law, which is law of conservation of momentum. First, we want to know what is Newton's third law. Okay, so when two bodies are interacting with each other, and if one body applies a force on another body, the second body simultaneously apply the same force on the first body in opposite direction. This is Newton's third law, and we all are familiar with the famous statement that for every action there is an equal and opposite reaction. Okay, and the important thing related to Newton's third law, which we need to understand, is the forces that are acting, action and reaction forces that are acting on different bodies, not on a single body. That's why we cannot cancel these forces. Now, according to Newton's second law, we know that any force is given by rate of change of linear momentum. Let us suppose I have two objects or two metallic objects. First metallic object is this one, and second metallic object is this one. Let us assume it is moving with some velocity u1, and it is also moving with another velocity u2. These two are the initial velocities of body 1 and body 2, and their masses are m1 and m2 respectively. Let me write the masses here, m1 and m2. Okay. Now these two bodies are getting interacted with each other. So when these two bodies are getting interacted with each other, means you will have this situation. Now after impact, means after interaction, the first body will apply a force on second body, and the second body also applies the same amount of force on the first body but in opposite direction. Therefore you will have some final velocities of the two bodies. Okay, let me assume that for first body the final velocity is v1, and for second body the final velocity is v2. Okay, their masses are respectively m1 and m2. Now Newton's third law, according to Newton's third law, the forces which is applied on both bodies, means the force which is applied by first body on second body, and the force which is applied by second body and first body, both are equal in magnitude and in opposite direction. This is according to Newton's third law. Therefore we can write this as F1 bar, means it is the force exerted on first body, and it is equal to minus F2 bar. Okay, this minus indicates the action and reaction forces are opposite to each other. Now in place of forces, we can take a rate of change of momentum. Therefore what I am trying to do now is, in place of f1 I am taking it as delta p1 by delta t, and it is equal to delta p2 by delta t. Okay, these are the rate of change of momentums of both the bodies, but with a negative sign for the second one. Now cancelling delta t on both sides, so I am just cancelling the delta t on both sides. You will have, let me write this one as delta p1, and it is equal to minus delta p2. So what is delta p1? It is the change in momentum of body 1. Therefore change in momentum is nothing but the final momentum minus initial momentum. Therefore how can I write this? m1 v1 is the final momentum minus m2 v2 is the initial momentum. Okay, sorry, final momentum minus initial momentum, sorry for that. So final momentum minus initial momentum of body 1, and it is equal to negative of final momentum is m2 v2 for body 2. Initial momentum is minus m2 u2. Okay, now arranging the terms based upon their masses, means I want to consider the momentum of first body on one side and the momentum of second body on another side. Okay. Now what I am trying to do is I am just taking here. I am writing this as it is: m1 v1 minus m1 u1 is equal to minus m2 v2 plus m2 u2. Okay. Now negative terms I'm sending to opposite sides so that I will have all positive terms. Now what I can write is m this equation can be modified as m1 u1 plus m2 u2. It is equal to m1 v1 plus m2 v2. Okay. Now what is the thing in the LHS will give us? What is the thing in the LHS give us? LHS give us the total momentum of the two bodies before the collision or before the interaction. Okay. So what this LHS term gives us? Total momentum of the system. Total momentum of the system. Why I am calling this a system? Because I am considering both the bodies. Okay. So total momentum of the system before collision or before interaction, okay, is equal to, what is the term in the RHS tells us? Total momentum of the system. Total momentum. So the total momentum of the system before collision is equal to total momentum of the system after collision. This is called as law of conservation of momentum. Law of conservation of momentum. So one of the application of Newton's third law is law of conservation of the system. Okay. If total system, when the net force acting on the system, or when there is no external force acting on the system, and if you consider only there are internal forces, then the total momentum of the entire system is conserved. Means the total momentum before the collision is equal to total momentum after the collision. Okay. I hope it gave you some insight related to Newton's third law and its application. If you really like this video, please hit a like button and subscribe to our channel. Thank you very much.